So let's talk about objects just from a practical standpoint, and then we'll get into nitty gritty of how do you define them and use them. Let's go to full. There we go. Okay, can you see my slides here? The whole thing? Let's see. Lenny, just to pick somebody.
Yes, sir.
Okay, great. Okay, so here's your game board, and I've thrown on just a couple of gray hulls here. This is actually going to be pretty much what your ships end up looking like once you add them next week. But let's just think about how we would represent ships in Python. Right? So I want to think in two classes of ideas, right? We need variables that sort of track their state and functions that allow us to do things with the ships. Like we should be able to check if a particular guess is a hit. So if I get the coordinate A2, I should be able to run some function that says like is hit, and then I can get a true or a false out of that, right? The variables would be something like the location of the ship, right, or the current kind of hits on the ship. So maybe we'll just brainstorm together here, and everybody, you can just shout out I'll try to draw them on the slide here. What are some variables that you think we would need, to track the ships, their state?
Ship position.
Okay, position. So is this going to be a disaster? Yes. Answer, most certainly. God. All right, position. God, technology's going to be a death me here. All right, let's go ahead, and I'll just we'll remember it down. I will figure out how to do the pin PowerPoint thing later. It's doing some kind of shortcuts. Yeah, so we want position. And what does position mean? How would I actually make a variable? Like, how would you describe this to somebody who can't see the board where the submarine is? Like, so they can place their submarine in the same spot. Okay, XY coordinates, right? In the concepts of battleship, it would be like row and column. So, what is the row and column of the submarine? Greg.
So you said, what is a column?
Right, so the rows would be A through J, and the column would be 0 through 9.
So it'd be like 2A through C. That's what you mean.
Yeah, well, and now you brought up a good point, right? Maybe we need more than just a single row and a single column. So you said like we'll have the rows be a range, like A through C, I guess, and column be a number. 2. But if we say, fine, row will be a variable that is actually an array, and column will just be a single value, that works for the submarine, but does it work for the aircraft carrier? Do we understand the question?
You have to like make them vary depending on what type of like submarine or aircraft they are, like the size and.
Okay, the size and the orientation, right? The submarine is vertical, and the aircraft carrier is horizontal. So if we say that the position of the ship is actually its bow, I swear to God, who makes this stuff? The bow here, fine, that's a single coordinate, and then if I combine that with the orientation, whether it's vertical or horizontal, and also the ship length then, whether it's 3 or 5 wide, right? So let me just try to skip ahead here, and let's look at the top section. These would be enough pieces, variables, to actually recreate this board. Somebody else could recreate the board based on this information, right? If we gave them these variables, like just on a piece of paper, it doesn't have to be code. You could say, hey, set up your board so it matches mine. Here's my information. And that captures what we'll call the state. Yeah? So look through these 4 variables per ship and try to convince yourself that this is enough to recreate this game board. And if you don't understand, if you don't think it is enough, let me know. What do you think? Does it make sense? So like the hits, what kind of data type is the submarine underscore hits? Riki, what do you think? Do we have, where's the class? Let's see.
Sir, is that just, I don't know.
I can't really read it, to be completely honest. It's a little bit blurry.
Okay, let's see. Maybe we can, let me try something else
Yep.
here.
It might be just me, though.
Let's try to do it a little bit smaller here. All right, is that bigger?
Yeah, that's better.
Okay. So right here, the hits thing and this hits, like reading these brackets, what does that tell you in terms of like Python syntax?
That's like, do you mean like that's like the location of where the hit would be?
Right, so a hit is a
like
a little
F4
list, right?
F3.
F3 is a 2-element list. And then the hits plural is a list of lists, right? Each one, so there's 2 braces here indicating that what's inside of this, main list are a bunch of items. Each one of those items is itself a little list of 2 coordinates. Can you understand how to read that syntax? And so for the top one, there's only 1 hit, but I still use 2 braces here because it's a list with 1 item in it, and that item is B2. Does that make sense?
Got it.
Okay. So, how would I, given these variables, figure out whether a ship, a particular guess that someone gave me, like J9, hit the submarine or maybe hit the carrier? What would we need to know? And here I've got this is hit, but let's just scroll past this. If anyone was looking, then I guess they know the answer. But what kind of which of these variables do you need to have access to in order to figure out whether the submarine was hit by J9? Do you need to know its bow, its length, its orientation, its other hits? Some of them, all of them.
Bow length and orientation.
So bow length and orientation. We probably don't need to know the other hits. But if we're at a function, our function would have to have these 3 inputs: bow, length, orientation. Okay, as well as guess. Right? And so here we go. Here's the definition of this function. This is the top part of it. We'd have to put in this many parameters. You see that? That's kind of a mess. We have a function that takes in a bow coordinate, a length number, an orientation value, whether that's the string horizontal or vertical. I'm actually passing in hits. We've decided that's not strictly necessary, but we'll find that it's useful. And then actually the guess. Right? So you see that this function requires some knowledge about the ship, which is captured in the first 4 parameters. So these represent the ship.
Sir, can you zoom out?
Zoom out. Let's see. Can you? What can you?
Maybe like scroll down a little bit.
Let's see. How are you seeing my? Okay. So I only want you to look at the top row of this function right now.
Can't see any of them.
We can only see the variables.
You can't see function to check.
Now we can see define is hit and what would be entered into that function. Thank you.
Why do I see a different... Oh, man. All right, somehow you guys have a different view of Zoom than I do, but fair enough. Okay, well, keep me honest here then. Bow, length, orientation, hits all relate to the ship, and guess is the thing that somebody guessed, right? So how would you actually write this code? Now we'll scroll down. It's gonna drive me bananas. All right, can you see the whole function now?
Yes, sir.
Okay. So based on the bow location, orientation, and length, we can figure out whether the guess is on that ship. Okay, now to actually do that, to figure out whether is hit is true or false, would require some thinking, and you'll actually do that. You'll write those loops and conditionals to say, okay, let's start at the bow and go down one and see what coordinate that is and is it true. So let's forget about that and just say we can figure out, given those variables, whether we've got a hit. Okay? At which point we could say if is hit, return true, else return false. Okay? But I also want to update the hits array, right? That list of whether or not the ship has a hit on it, because I need to keep track of that to know whether I've lost the ship and where to place the red dots, etc. Okay? So wouldn't it be nice if I could keep track of that bookkeeping inside the isHit function? I mean, you could imagine whoever called isHit could then, if it's true, append a value onto the hits array. But it somehow makes sense to keep track of that in the isHit function. Right? Somehow the ship should be able to, like, if you hit the ship, it should update itself. So here, I'm actually taking in this parameter hits and adding the guess to it if it was, in fact, on the ship. Okay? And so here, this function is actually modifying one of its own parameters. We're returning a value, but we're also changing hits. Okay? And so this is what you would have to do if all you knew about Python was what we've covered so far, right? And how many ships are in Battleship? It's like, a little 2 destroyer, and then we've got the submarine and the cruiser and the battleship and there. So there's like 5 ships, right? Look how many variables you'd have to define and keep track of and pass around, right? This is a mess. And then ships are kind of a simple object. You can imagine more complex things you'd want to model in software that have maybe dozens of attributes. Making a variable for each one of those and then actually prefixing that variable with the object itself, it becomes very tedious. Okay? So let's see, and now maybe I'll go back into my presentation mode here so that you can see better. All right, and here's the big concept. We want to combine functions and state into one kind of thing. And then we're going to call that an object. And so objects are software structures that are used to model real-world things, like nouns. Right? So here's some examples. Say you wanted to make a program that simulated cars driving on a highway. Well, part of that simulation would certainly involve the concept of a car. And some things that you might want to track about each car is its respective fuel level, its mileage, its color, its model. And that's just a few things, right? What are some other aspects of a car that might be interesting to track in a simulation? Excuse me.
Speed or size.
Size, right? Number of passengers, maybe. Damage level, if it's going to be a Grand Theft Auto type game. right? There's a lot of attributes that are unique to each car and may change throughout the simulation. Do you understand the idea of state variables? Does it? I'm just staring at my own screen here, so I don't see your faces. But are we? The idea that cars can have state.
Yes.
Okay, so this is the same terminology that we'll use like back in your 300 classes when you talk about like state variables in a circuit or in some dynamic system, right? The current in an inductor, whatever. It somehow allows you to recreate the situation in another area, right? So if you know all the state variables of a car, you somehow know everything there is to know about that car. Okay, now once you have those variables, those are going to change throughout the simulation, and you could have a function that takes in, a bunch of fuel levels and mileages and colors and has like 35 parameters, and you do something interesting with it. But it'd be much cleaner if you could actually combine the state variables along with some methods that operate on those state variables, right? So maybe we could define a method called refuel, right? And refuel, if we called that method, would change which of the state variables, do you think?
Fuel level.
Fuel level, sure. And what would if you wanted to refuel your car, what would you have to provide as input to that function?
Fuel amount.
The number of new gallons, right? And so the body of that function might just be one line. Fuel level equals fuel level plus gallons, right? And then I could have another method called drive, and drive might take a destination parameter, and how you specify that depends on your simulation tool, right? How you're setting that up, but maybe it's an XY coordinate, right? Or maybe it's the name of a city. But regardless, what state variable would that change? Maybe more than one.
Mileage and fuel level.
Mileage and fuel level, right? The fuel level would go down and the mileage would increase. Okay? And so the only way you should interact with a car in your simulation is through its methods. You should never directly change the fuel level. You should only refuel your car, and that will keep track of the fuel level. You should never tamper with the mileage. You should simply drive the car, and the mileage will update itself. Just like your odometer, it's not like you go in there and set the number directly. You actually operate on the car, you drive the car, and the odometer somehow keeps track of this. Okay? Another example would be like a printer. You have some state that it knows its ink, it knows how many pages it's printed. Okay, and it maybe only has one method here, print, and then the input to that is a document. Now, how you structure that, it could be, the name of a file, it could be the actual PostScript, figure codes, but when you print the document, I would expect the ink levels to go down and the pages printed to go up. Okay? So we could print a document, print another document, and at some point we might run out of ink, right? You could actually write inside the print function here this method to like raise an error, to say, hey, if ink level is less than or equal to 0, don't print it. Instead, pop up a message to the user, right? In the car, our return value for drive could be a true or false. Like, did you actually get to your destination or did you run out of fuel? Right? So drive could return a true or a false based on how much fuel you had in the tank. And if it was false, maybe it also displays a message like, sorry, buddy, you ran out of fuel. You should refuel. Okay? So these objects combine state along with methods. What do we think? This is like just the high level concept here. We'll actually like reduce this to practice in a minute. with some examples actually writing in Python. But the core kind of concept here is that objects, real world things, have state and methods, and when we model them in code. Okay. So let's stop the PowerPoint because I'm honestly fed up with the with the user interface here and how I can annotate these slides. I had a bunch more interactive kind of presentation idea in mind, but let's go ahead and drop over to PyCharm here and see if we can play around with writing some actual class objects and using them. Okay. So go ahead and give yourself whatever project you're in. Just open up PyCharm. It doesn't matter. If you're currently in the Battleship project, that's fine. Just right-click and right-click on the top folder right there. Just say New File, and give yourself a new file called like scratch.py. Okay, and we'll use this to just play around and create some objects and play with them. Okay? So do that. Give me 2 minutes here. I've got to square away some things with my son, and then I'll be right back. Hey, John. How about this? Do you see a Peter Shop? Yeah. And you ate it? Great. So, noon. Noah asked you to come over. Like, you bike over to his house at noon? Is it pretty cool? In half hour. 30 minutes. Alright. And I'll invite you down there with me. That's my class. I'm in the middle of class here, so I've got to go back. But basically, I'll take about a minute to bike there. I think we probably play until class starts. And this is your class, right? So then I'll come grab you, we'll bike home, and then go back to school. Sound good? No.
Come on, Jake, let's go outside.
Yeah, perfect.
Sorry. For 30.
All right, sorry. Things are dynamic at the Donald household today. I don't know if you've gotten the impression of that or not. But so let's go ahead and just try to create this idea of some cars, okay? Now, when we looked at that slide earlier, we had the name car. And that is the most abstract sort of idea. It tells me, here are the rules for a car. It's got these kinds of variables, and it can do these kinds of things. But that itself is not my Toyota Corolla, which is in my driveway. That is the idea of the car. Okay, so we'll call that the class. The first thing we'll do in code is define what it means to be a car. We'll define the class. And then we'll create cars. All right, so the particular car itself will be called an object. And so we'll use the class almost as a cookie cutter to create cookies, right? To create objects. And so that's the nomenclature we'll use. The class is what you'll actually write in code, and then you'll use the class to create objects. And those objects, you can then drive them around, you can change their color, and go about your business. Okay, so let's try to create the car class. Okay. And all you need to do that is type the word class and then give it a name. Now, typically, by convention, the names of classes are capitalized. So capital CAR. Can you see my screen okay? Does this big enough font? Okay, great. And so you should be typing along here, and making sure that you can run this as well. Okay. So the trick, if I define, now we're gonna make the methods, right? Let's make the refuel method. Refuel. Notice when I hit the parentheses here, I get self. Did you see this? How it filled that in? Okay, that's just the first parameter to the function. PyCharm is clever enough to know that since I'm inside of a class, the first parameter to the method should be self. But it's just the words self. It's not anything particularly special. Let's just keep that there, and we'll see why we need it. And then let's put what's the input we expect to send refuel? What do we give it?
Gallons.
Gallons. Yeah, so the gallons. Okay. Now what I want to do is add that gallons to the fuel level. Now where is fuel level stored? That's the question. Right? Fuel level is something that the car knows about and can keep track of. But how? Right? Well, the trick is this variable called self. So you can think of self as like a big box that you can put variables into and somehow they are remembered. Okay, we can just create them out of thin. We can say self.fuel equals gallons. And then later on, let's just put that right there. And then let's go ahead and say that's fine. Somehow we've given the car some fuel. And now I know we didn't say plus equals gallons because we would need to initialize fuel to some value. We'll talk about that in a little bit. But let's just let's keep that and def drive. And what would drive? I gave it a destination. Let's just put number of destination is actually number of miles. So self.mileage is just going to equal destination. Okay? And we're gonna fix these up by using plus equals and stuff like that. But let's say self.fuel, and whatever it is, you use 2 gallons to get there. We're gonna have to improve our class. But now we've got 2 methods, and that's enough to get started. My car can be refueled and my car can drive. And when I call these methods, it changes its state. So let's go ahead and give ourselves a Toyota. Okay? So we'll just say...
Sure.
Oh,
So
yeah.
what's the hyphen next to the equal sign? By 2?
Oh, this is a shorthand notation for this. Self equals self dot. Right, subtract it from itself. Minus equals. You can also say plus equals or times equals to multiply it by itself or add something to itself.
Perfect, thank you.
Mm-hmm. All right, so let's give ourselves, so create an object from the class. Right, so Toyota equals car. And I'm going to put these 2 parentheses after here to indicate that I'm creating a car. And let's just throw in some print statements so when we call these methods, it's pretty clear what happened. Okay, so throw in some print statements there. Okay, so now we can actually use our new object by calling its method. So I can say, let's put some fuel in the tank. And then I can say Toyota.drive. So the syntax to call the method is to put a dot between the object itself and the method you want to call. And this should look familiar to you from the embed world. In fact, embed was using objects the whole time, we just never told you. Right? So you would say motor.speed, right? That is a motor object and you're setting the speed of it. Right? Or the digital I/O, right? All those pieces were they're actually C++ objects. And we only really talked about C, which is a subset of the language. So you've been using objects your whole, EW life, but now you're only now realizing it, right? So to run this, we'll need to edit our configuration. So go ahead, Greg.
After after Toyota.refuel 10, is it underscore or pound sign? Is that?
Oh, this was just a comment, right? The pound sign is just me being, showing you what I'm doing in the code, right?
Is there an underscore after the second parentheses?
Oh, no, that is a grammar check from PyCharm saying I should have two spaces.
Okay. Yeah, thanks, sir.
Yeah, I'm sorry. Right. So if you the recordings are actually a much higher video quality than these Zoom casts. So if you want to go back at all and see some chunk of class, just make a note of roughly how far in it is, and then you can scroll through and you should see a high resolution video. I'm also in the process of recording the lectures as standalone videos, and so I'm hoping that'll be a good reference as well. I'm still getting used to all the limitations of this Zoom thing. Any rate, these are just comments. Okay, so let's edit this configuration here. I'm going to give myself a new Python execution thing, and I'm going to call it Scratch. And I'm going to, when I click play on the Scratch, I don't want to play the main battleship thing. I just want to play the Scratch file. Okay? And so now you see the title of my runtime environment is Scratch. When I hit play, you see the result of my execution. And I would encourage you to create this file like Scratch here, because then you can actually play around with some of the battleship code, and we'll talk about how to do that later, outside of the game itself. So if you want to play with the ship objects and try to figure out how they work, or the player objects and other things, you can play in this little Scratch file. Okay? So the real concept here, and the way, and now each language is a little bit different in how they actually implement objects. In Python, the first parameter to every method is the self variable. Okay? And that is like the brain, the memory, I guess, of the object. So these methods themselves are like a shell, and you populate it with the memory of whatever particular object you're using, and that's the self piece. So then the Toyota, when it runs the refuel method, it's using its existing 10 here. If I created another one, like minivan, takes more fuel, right? And minivan.drive, these are two different cars. These are objects that come from the same class. And so they have the same capabilities, but when I call drive and I called it on the minivan object, I get a different mileage and a different fuel level than if I called it using Toyota. Okay, so the real trick is to remember that self comes for free. Drive, if you look at the definition, takes two inputs. The first one is provided by Python itself, which looks to the left of this method and goes, who called it? Oh, minivan. I will put that self in front of 35. Or Toyota, I'll put that self in front. Okay? So the last thing I want to cover, and we'll go over this all again. I'll try to get the annotation working. I think it would really help. But the last thing I want to cover is how do I initialize these cars? And the problem we're seeing here, right? What I really want to do is start when I create a new car, I would like to set the fuel level to 0. Right? I would like to set the mileage to 0. It's a brand new car right off the line. So how do I initialize the car this is me building a car right here. I'm calling this actually looks like a method to me. This is a function. I'm calling some function here. You see that? That parentheses indicates there's a function that's being called. That function is called the constructor. That builds the object. By default, the only thing that constructor does is create an empty self. I can implement my own constructor and do something special to it if I create a constructor function. Okay? Now we have to give this function a very special name so that Python knows it's a constructor and not some random other method that we decided the car should be able to do. All right, and so the special methods in Python always begin with 2 underscores. And that's how Python knows they're special. So let's write this out. Def and underscore underscore. And you'll see a bunch of options here. These are, and you'll see they're all to the right. They say predefined. Those are all the things your object can do because it's an object, and they're just the default implementations. I want to create my own type of constructor. So I'm going to say def init. Okay. And then I can say print building a car. Okay, so let's just play it here and see the output. Now you see it says building a car and then building another car. Because down here I've defined a Toyota and a minivan. If I move the definition of minivan up, I'll see building a car twice. Right? So that function is getting called right away. That's building the car. It's not doing anything special right here, but notice I have access to this self variable. So here's where I can set an initial fuel level. Self.fuel equals 0 and self.mileage equals 0. If I didn't do this, say I don't do this, and I go down here and say self.fuel equals self.fuel plus gallons. What happens when I try to refuel my car? I get a use before defined error, right? I'm trying to reference some value fuel which I have never used before and therefore don't have, it doesn't have a value. So what I can do is give it an initial value, set it to 0 right up here, and that way when I refuel my car, it works, right? So this is the last thing I want to show you is that these things can keep track of their state. So Toyota.refuel, and let's give it 5 here. So now I've filled up with 10, and then I filled up with 5. Do you see the output here? It's able to keep track of its fuel level. I gave it 10 gallons, and then I gave it 5 more gallons, and you see at the second run of that method, the car knows that it has 15 gallons of fuel. Okay, and the minivan is only going to have 3 gallons of fuel. These are separate objects. Even though they share the same class, they each keep track of their state separately. Their fuel and mileage are both separate. And they're tracked in one thing we'll call an object. Okay? And notice how we're interacting with these objects through the methods. All right, so let's pause there, and I'm sorry for the kind of helter-skelter structure of the lecture today. We'll hit this again on Wednesday, but the try to go through this material. You can also use Google. I think there's plenty of resources on the web to also look at. We're going to hit objects again on Wednesday, and they're really going to be fundamental to how we write code in this class. All right, so this is kind of the biggest programming, new concept we're going to cover, and it's important to get a good foundation for how these things work. Any questions right off the bat? All right, I will post this recording later today, and we'll go over the same lecture slides on Wednesday. Your lab on Thursday will require you to start using objects, and you'll actually create ships for your game board. Okay? Good to go? All right. Appreciate your flexibility, and I will see you on Wednesday.
Thank you, sir.
Great.
Thank you, sir.
All right, bye.
Sir, I have a quick question.
Yeah, go ahead.
Just more of like Python syntax for full colons. Do you mind if I just throw my screen up really quick?
Yeah, of course.
Oh, it says disabled.
Oh, let me go ahead.
For example, when it's like declaring my board colon game board is equal to, and then initializing that object. What is the purpose of the colon right there?
So that is we're not going to really cover it in class. It's called a type hint. So in C, you wouldn't be able to just say my board equals game board. You have to say that the type of my board is a game board, right, or an int x or a float, right?
Okay.
So C has a strong typing. You can't use a variable without declaring its type. In Python, you have implicit typing, where you declare a variable, and by setting it equal to something, that's how it gets its type, right? That works great, and we don't have to do anything different. The problem is when you're writing code and you want to get the suggested completions. So if you say my board dot something, you'll see it pop up with a bunch of options.
Yeah.
Right? It only can do that because I've given it the hint with that colon that it is a game board.
Oh.
If we remove that,
So if I did like Lenny board is equal to.
Yeah. Now, PyCharm's getting more and more clever, and so it can start to infer.
Okay.
Like since you're in the same file as where you declared it, as where you ran game board, it can figure that out, right? It can go back up higher and say where did you first declare it. The problem is when you pass them into functions. The method, once it's inside of a function, it doesn't know where it came from, and so it'll lose that capability to give you the auto completion.
Okay.
So it's just something I've added, and to basically all the variables to make sure the code completions are meaningful.
Okay, and is that name like the game board name? Is that just referring to the object of that name?
Yeah,
Okay.
right.
Okay.
So you see like screen on line 16 there.
Yeah.
Right? The thing that comes out of pygame.display.set mode is a surface object.
Got it.
And that's coming from the Pygame library, so it's pygame.surface.
Okay, cool. Yeah, I was just trying to figure out what was really going on there, but
Yeah, and I'll mention that in lab on whatever Thursday, but it really is not part of the core Python experience. It's just a thing you can add on top to make PyCharm work a little better.
awesome. Thank you, sir.
All right, great. And I saw your thing about FFmpeg. I picked up the new cameras over the weekend, and so I'm gonna mount those, and I hopefully get that to that today, and I'll be able to do some stuff with them. But yeah, we'll see.
Awesome.
All right, good.
Have a good one, sir.
You too.